were calling and asking for help, it was like
Their
2 or 3
grandchildren.
generations down the line that didn't know.
Sure.
And it was one of the things right now where they're trying to figure out ways to prove it, like genetic markers or whatever, like how is this happening? Because genetics theoretically shouldn't be able to be changed once they're already set.
Based on what we believe genetics
be
looks
set,
like.
yeah.
Right.
And then they're trying to tie it
We're
into
actually
cancer,
editing the...
too, because cancer is a mutation of a cell.
Sure.
And it's basically like, you know,
A cell that grows out of control.
yeah, out of control. They're trying to, how does this happen? Like, what causes this? And are there chemical markers within animals that say, this is an experience, but is it tied to cancer and stuff too? And
It's fascinating.
They're trying to figure out mathematically how to...
Oh, and this is it. This is the mathematics behind it. It's actually, the trick is, are we asking the right questions and collecting the right data, which is always the case. This kind of stuff takes years and 40 years to figure out. Because you have to cover every single possibility, look for changes and look for changes.
And you can't do it in a lifetime, like it's...
Oh no, this carries on.
Several, yeah.
What's that movie with Will Smith where he's actually doing it with the, oh my god.
I Am Legend?
Yes,
Yeah.
the one where he's in his basement. He's like the only survivor of the apocalypse. And he's actually testing each trait, and he stumbles upon that one, he's like, I got it, and then it backfires on him. It's like, damn it, and you can, it's amazing, it's a movie, and it's a little bit far-fetched, but the science, what he was doing right there is brilliant, because he gets frustrated because he thought he was getting close, and then it backfired, knocked him back into that null curve. It's so frustrating to constantly get no results, and never have something pop off, especially if you're a research statistician. I mean, if you're working at a big university, there's an old phrase, publish or perish. The idea, I have no desire to work at a research university because I want to be here with you guys talking about this stuff and having you guys learn this and kind of seeing the utility like me. I don't want to sit in my office and publish papers all day, number one. And number two, I don't want to deal with that frustration level, having to come up with something interesting just to publish it. It's one thing to come up with something you're interested in. It sounds like Harrison's got about 12 good ideas for us here.
I just thought it was...
It's very interesting. JC, go!
So, right there, you were just saying you're doing it over and over and over again. You're getting your null hypothesis.
On different hypotheses.
Okay, so you're just asking different questions.
Exactly.
So you find the right questions.
Essentially, yes. Am I looking at the right thing? That's called data mining in some cases. When you've got a bunch of data, you're like, okay, are any of these related to each other? Let's test these. Nope. Let's test these. Nope. Systematically, let's invest. Exactly. Is it this marker? Is it this marker? Oh crap, this marker might be showing something. Replicate that, try it again. Fair enough? Good. Alright, back to the green tea and breast cancer article. How many of you have heard that green tea is good for you? Many of us have heard this green tea is good for you. How many of you drink green tea because it's good for you? How many of you drink green tea because it tastes good? Yeah, it has the benefit of tasting good, which is nice. How many of you knew that green tea and black tea are the same plant? Green tea is a different way you process it. Black tea is fermented, green tea is dried. Same exact plant, but there's something chemically compositioned differently. And white tea, white, oolong, black, and green are all the same plant, just how it's processed. White tea is the baby leaves, and green tea is dried leaves, and black tea is fermented leaves, all the same tea, But for some reason, and I've got a little graph here that I thought was interesting from OSU, about the makeup of green and black tea as far as the chemicals in them. That is a result of the difference of the processing, which I found very interesting. But the tie has been, okay, green tea might help with breast cancer. In short, knocking it down. Where would that hypothesis come from?
Seeing a lower rate with people who, the population that are smoking tea.
And where does that happen? Generally not in America, at least not in the past 100 years. Generally overseas in Asian cultures. And that is actually nodded to in this article. Somewhere in this article, I believe, it mentions the fact that we tested highly in China. And if you look at the names of the folks on the in the actual article. I mean, you can tell when the study was. If you read the article and actually look at it, it was done on an Asian population.
How do they focus on green tea rather than fish or rice or any of the other billions of things that they eat that we don't?
Because, assuming they've controlled for all those dietary changes, the only thing that's different is whether or not they had the green tea.
You think they tested rice and fish and all the other stuff?
But that's the thing. It doesn't matter if they did or not as long as it's controlled for. As long as both the control group... Go ahead, Dean, explain.
So they went to China, and they just tested Chinese with
Well, I
who all
realize...
ate rice and fish.
My point is, how do they pick green tea?
Oh, that was the hypothesis. That's the hypothesis. They might have done one on fish and said, no, it's not fish.
That's what I was saying.
No, that's what I'm saying. This is like JC's question. Maybe they did test fish and rice and bamboo shoots. Who knows? But the idea is that none of those, I'm guessing, popped up with significance, and they said, okay, let's try green tea.
That's what I'm asking.
Boom.
Did they test against other?
I don't know, but this particular one tested the green tea. That'd be interesting research to check out. Yeah. So we tested green tea versus not green tea, all else being held equal. Fair enough, good question, very good question. So this happens. Notice it said the proportion of lost or non-responding patients was about 1.2%. That's actually pretty damn good. A lot of times it's got more zeros than that, like 10%, 50%. Sometimes you lose a large chunk of your study. And some of that can be attributed to attrition, unfortunately, who will actually die in the study. You know, I mean, if we're checking breast cancer rates, that's most likely some women are contracting breast cancer, unfortunately, and some will die from that. So you might lose, through natural causes, some women in the study. Similar to the percentage of the controls, so you've lost roughly the same amount, which that makes me happy when I see that, because it means chances are the two groups of women are fairly identical in physiological makeup. Okay? Potential control women were excluded if they had a previous diagnosis of either breast cancer or some other malignant disease. You don't want to go in with that. Why?
Reoccurring.
Oh, good. They could pop back and reoccur and drive the breast cancer rate higher artificially. Pre-existing condition. We want to try to see it from the bloom phase onward, if you will, rather than a reoccurring or pre-existing condition. You ready? Here we go. What is the study trying to show? Now, very often, the research hypothesis is called either H sub 1 or sometimes H sub A for alternative hypothesis. What is the research hypothesis that we are trying to show? Put that on the board. What is the research hypothesis trying to show? Green tea will lower breast cancer rates. So H1 is that green tea will lower breast cancer rates. There's a word very often that gets left off of these statements, and that word is significantly. That's implied though. Deanne's got a good point. Wait a minute, time out. You kind of have to have the word significantly in there. Assume it's in there by default. These are often called, speaking of which, hypothesis tests are often called tests of statistical significance. So if you get a positive result, it's statistically significantly positive. So take that for granted when you see the results. What's the null? H naught.
Green tea will not affect the.
Can we just say not lower?
Yeah, not lower.
Is that okay? Go with the exact opposite, yeah. Not affect is a fine way of saying it, but if you just say, let's write down this.
It could hack and bring.
Good, thank you, Kate. Will not lower breast cancer rates. I love what you just said, and I love what you just said second. So Kate said, wait a minute, green tea will not affect breast cancer rates. I know what she meant, and then she corrected herself. She said, green tea will not lower breast cancer rate, because you don't want to say it won't affect them, because if you say it won't affect them, it could be higher or lower. The opposite of that could be higher or lower. Now, if you come up with a study that shows that green tea raises breast cancer rates, that would be a fundamental quantum shift in dietary usage across the globe. If you think about that. Think about all the beliefs that have been held for hundreds of years, actually say hundreds of years, but proven statistically in the past 50. If you could overturn that, chances are you're not going to, and chances are if you do have a study that overturns it, what was it?
Outlier.
It was an outlier, false positive, boom, boom. Because there's already acres of evidence that show it's not true. It's not true. But the idea is you want to be careful about phrasing your hypotheses to make sure they actually say exactly the opposite of each other. It either lowers it or it doesn't lower it. Fair enough? You guys are great. All right. Let's leave with an image. Let's leave with an image, and of course you're going to leave literally with it because you're going to take it with you when you leave. Yes. Jesus. Green tea consumption was associated. Notice the careful use of the word associated.
Not proven.
Boom! Properly statistically said, right? It was associated with a reduced risk of breast cancer with a statistically significant test for trend. Look at this p-value, friends. P less than 0.001. Holy hell. Is that less than 5%? Hella less than 5%, yes?
So even with studies, you can only say that it's a correlation rather than a causation.
Oh, we have not proven causation.
That's the,
There are ways to show direction of dependence. If we have time, we'll get to it in this class. We often don't, because we take so much time on t-tests and z-tests, which I love. I'd rather spend the time and have you guys take 351, 352 and pick up the directional tests. Sally Clark, for example, is an easy example. There's also one I like looking at. It's data that shows attractiveness, perceived attractiveness of a plaintiff and guilt or not guilty verdicts in court cases. Very interesting study that shows that perceived attractive plaintiffs get more guilty convictions than perceived unattractive plaintiffs. Interesting. Now, no, the plaintiffs themselves get the guilty verdicts that you would. In other words, the jury's being biased by the attractiveness of the plaintiff. Does that make sense? I've never seen one on the other way with the defendant. That'd be interesting too. But the idea is, can you prove that the verdict is a result of this, or that this is a result of the verdict? Well, one like that, you can't go the other direction. You can't change attractiveness based on the verdict.
so there's too many variables for that.
For something like this, that's why I love the fact that it said associated, statistically significant test for trend.
That's why you can't use proof by contradiction for this thing, right?
You can't prove that green tea is lowering breast cancer, but we have proven by contradiction that it's associated with a lower risk of breast cancer.
This is why.
Oh God, no, and you usually can't. Dan wrote this about a week ago. Yeah, you generally can't say this causes this.
You can
say this appears with this. This appears, increased consumption of breast cancer. Increased consumption of green tea correlates with lower risks of breast cancer. So friends, real quick, take this graphic with you. Here's the average rate of breast cancer in the population. That's the average rate. I don't know what it is, and it doesn't matter right now. What's happening right now, if I go this way? Increasing rates of breast cancer. What's happening now?
That is a very, 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 very small number.
Oh, yes! Exactly. Notice where I put it. I put it way the hell down here. Because now this is all 5% right here. This is all 5%. So you're 95% confidence interval, one-sided, yes. Which means this whole red thing is 5% and we popped way the hell down here. More tomorrow on what way the hell down here means and what it doesn't mean, because it doesn't mean something too. But, let me ask you one question. Does it look like we can associate increased consumption of green tea with lower breast cancer rates? It sure does. We can't prove that it causes it, but can we say it looks like they're associated? That says they're associated because it doesn't look like they're not.
If I was given it, I wouldn't argue with it.
We'll come back. Good. We'll come back to this one, yes? Bring everything with you. Obviously, bring the sheets with you. Bring them back. We'll play with them again on Wednesday. Cool? And bring your questions if you have more questions. Remember, you got your exam for Wednesday too. Remember that?
Speaking of, I have a question.
Well, good. Let me shut the camera down. Or we can turn the camera up.
No, down.